So for this problem, they're talking about mu sub d, okay? So what that means is the mean difference. So we calculate something called differences in paired data, which means, when we have a set of numbers, maybe call them x1 and x2. Let's say like you want to know whether receiving instruction in a certain math course is helping your math grade go up. So like maybe some students are taking the AP statistics exam. Maybe they can take a practice exam before, and maybe they get a 3 out of 5. Probably not if they haven't even taken an AP class. And then they take the exam after having the instructor. Okay, so you're comparing two numbers that come from the same person. So we call that a dependent sample. And then you're interested in the difference in their scores. Okay, we'd probably actually switch these around. We'd do 5 minus 2. The score went up by positive 3. Okay, so that's this column. This new column D is when you take paired data and you add them or subtract them in some way, usually subtraction. Okay, so like maybe another student just had already known something about statistics and they got the same score after having the instructor. The difference is 0. Okay, so that's what mu sub D is. It's the population mean of the differences. It's the mean of this column of differences. Add them all up, divide by how many there are. All right, so let's see which hypothesis is appropriate here. A doctor wants to research if there is any difference in birth weights. If there's any difference, then the doctor's not saying whether they think it's greater or less than. They're just testing for difference, so we know that's the does not equal symbol. Okay, so you probably could have got that right without knowing about mu sub d, but you're going to see that symbol again.